Moving on to question 18, given the following half pipe, how many times can the skateboarder go back and forth until he stops? Assume the pipe is frictionless except for the red length that has mu sub k equals 0.1. So for this equation, we're going to assume that we've got no friction along these entire lengths of the pipe, and we are only worried about this small red section here that has a coefficient of kinetic friction of 0.1. And so we're going to approach this problem using our conservation of energy equation, which I have written out below, where we have our initial kinetic and potential energy equal to our final kinetic and potential energy and any external energy added or subtracted from the system. And so the U in this case is going to be that friction that takes energy out of our system during that L length section. And so I think breaking down this equation and writing it out a little bit more, we can see that our initial kinetic energy we know to be 1/2 times mass times our initial velocity, and then our initial potential energy being mass times gravity times our initial height is equal to U plus, again, the final kinetic energy, which is 1/2 m times our final velocity squared, plus our final potential energy of mass times gravity times our final height. So we can simplify a lot of the variables out of this problem to begin with. First, looking at our initial velocity, our skateboarder is going to be initially stationary as he drops into the pipe. So he'll have no component of initial velocity. And so we can set that equal to 0. The initial height is going to be equal to that length L, as we see right here. And so we can kind of substitute that HI as an L. We'll come back to the U in a little bit. And our final velocity, we know the skateboarder stops at the end of the problem. So our final velocity is going to also be 0. And our final height, our skateboarder will be somewhere down here when he comes to a stop. And so our final height is also going to be 0. Now that we've canceled some of our terms out, we can simplify the above equation to be mgl is equal to U. So what is our U in this equation? Our U is our energy of frictional loss. So we can write it as our U sub F. And we know that that is equal to our force of friction times the distance traveled. And so what is the force of friction? We can break that down further. We know the force of friction is our coefficient of friction, which is given to us as mu sub k, times our normal force. And then it's going to be multiplied by the distance traveled. And we can simplify that even further because we know that our normal force is equal, in this case, to mass times gravity, because during the L segment, it is completely flat. And so if we've got our skateboarder, he is just going to be experiencing gravitational force this way and normal force that way, which will be equal and opposite to the gravitational force. And so we know that that'll equal mass times gravity. So we can rewrite that as mu sub k times mass times gravity times our distance. And so we can simplify the above equation even further, writing it as mgl is equal to mu sub k times mass times gravity times distance. And so in this problem, if we zoom out a little bit, we're trying to solve for the distance because that is our only unknown variable in this equation. And if we solve for the distance, we can find out how long or for how much distance the skateboarder travels along the friction surface, and that'll tell us how many times he goes back and forth until he stops. So we can simplify this, canceling out a couple of variables. We've got mg on both sides, so we can just cancel those out. And we're left with L equals 0.1 d, because our coefficient of kinetic friction is equal to 0.1. And finally, solving for d, we get our distance is equal to 10L, and L is a given variable we started the equation with, so that is an acceptable way to leave it. And so if our distance is 10L, we know our skateboarder goes back and forth on the half pipe 10 times because he crosses that L segment 10 total times. The wording used here could be a little confusing with back and forth. I'm going to interpret it as how many times he crosses that middle section. And so the answer in that case would be 10 times because the distance traveled is 10L. And that's how you do this one.